All right, here we are, section 5.3, writing equations of polynomial functions. So, just starting off, just a reminder of the fundamental theorem of algebra for you. If we have a polynomial, the degree will tell you how many roots it has. So just something, again, to keep in mind as we go. Remember that imaginary complex conjugates always must occur in pairs. So for example, if you have 2 plus 3i as a solution, you must also have 2 minus 3i. The conjugate's just the same two numbers, just sign change. So if 5i was a solution, then negative 5i would also be a solution. Identify the factors of a polynomial function that has the given 0. So basically what it's asking is how could you get an equation whose answers are x equals 7, x equals 3, and x equals negative 4. To do it the long way one time here, really what you're doing is you're setting these equal to 0, so you're moving these numbers back over with the x, and so x minus 7 would have been one of the factors to get 7 as an answer. Same thing with x minus 3, or x equals 3, you'd subtract 3. You get x minus 3 equals 0, so that means that x minus 3 was a factor. And you could probably do this last one in your head, but x plus 4 is how you would get x equals negative 4. All right, so the next one over here to the right. So how did we get 2, 3i, and negative 3i? Well, to get 2, we had to have had a factor that was x minus 2, because if you set it equal to 0 and solve, you get 2. To get 3i, we would have had to have had x minus 3i. And to get negative 3i, we should have started with x plus 3i. And basically, I mean, I'll do this one just because we got something a little bit different happening here. So to get 8, we should have started with the factor of x minus 8. Now this one right here, 3 minus I and 3 plus I, the following one, these are a little bit interesting, so I'm going to go back over the side and do a little work. So we started with x equals 3 minus I. That was our answer. So in order to set it equal to 0, we'd have to subtract 3. So x minus 3 equals negative I. Still not equal to 0, so now we have to add I. So we actually started with a factor that was x minus 3 plus I in order to get this as our answer. And so kind of using that same process, if you want to do the work, you certainly can, but in order to get x equals 3 plus I, our factor that we started with had to be x minus 3 minus I. And I'll leave this last one here for you to finish up. So, write a polynomial function of least degree with a leading coefficient of 1 and the following zeros. So, it does say to write these in... Actually, no, this one doesn't say. So if it doesn't tell you to write it in standard form, just leave it in factored form, and that's it. So what that means is these are your zeros. So if we want a function, we need to start with f of x equals my leading coefficient's 1, so that means my first number here is 1. You don't really need it. And then because we can leave it in factored form, I just need all my factors that gave me these three answers. So to get 1 as an answer, I had to start with x minus 1, the factor. To get negative 4 as an answer, my factor had to be x plus 4. And to get 5 as an answer, I had to start with x minus 5 as my factor. And there you go. Met all of the criteria. So example number 4 here is very similar. I just want to point out one thing with this one. So we are writing a function. It does not say standard form. My leading coefficient's 1. So f of x equals, and then my leading coefficient's 1. That's the same as the exact previous problem. But my answers are 1, negative 2 plus I, and negative 2 minus I. So you got to use this same idea that we did here to get those factors. So to get 1, pretty straightforward. Your factor had to be x minus 1. To get negative 2 plus I, you had to start with x plus 2 minus I. And to get negative 2 minus I, you had to start with x plus 2 again. This time it was plus I. You'll notice really what's changing is the signs. I went from a negative 2 to a positive to plus 2. I went from plus I to minus I, and the same thing happened with the third factor. Okay, so I'm just going to do one of these, but this time it does want your answer in standard form, which just means you have to multiply it out. So here we go. First, start by writing in factored form. So f of x equals, now the coefficient's 1 again, so I'm not going to put a 1 here. I mean, if you really want, you can, but it's not necessary. My answers, though, so I have 1, 2, 3. Be careful, because anytime you have an imaginary number, but there's only 1, you also need to include its conjugate. So negative 3i is an answer, but that also means positive 3i is an answer. And most of the time, if you're given one imaginary number, it's your job to remember that there is another possible solution. So, writing these factors out, we had x minus 2, x minus 3, x plus 3i, and x minus 3i. So what you need to do is multiply these out, and you got to write it in standard form. So again, how you do this, honestly, it doesn't matter a whole lot. You can actually do 2 multiplication things at once. We can multiply the first 2 together and the back 2 together. So I'm actually going to go ahead and do that just to save myself some time and a little space here. So x times x is x squared minus 3x minus 2x plus 6. I'm going to clean that up right away so I don't forget. So x squared minus 5x plus 6. All right, now I'm going to multiply these back 2 together. So x times x is x squared minus 3ix plus 3ix, and then minus 9i squared. So cleaning that up, and again, I combined like terms here. I should have mentioned that to get negative 5 here. But cleaning these up, so negative 3ix, positive 3ix cancel, so that leaves me with x squared. Now we need to talk about I squared. Just a note, it's coming back now. I squared equals negative 1. So really that's negative 9 times negative 1, which would make that x squared plus 9. So there we go. But we're still not in standard form. We still have to multiply again. So you could, I just want to point this out, you could just distribute and then take the middle term and do the same thing, and then take the last term and do the same thing. That all works just fine. I just want to show you another way of multiplying though. So what you could do is make a box. Now I'm going to make it a 3 by 2, because my first polynomial has 3 terms, so I'm going to put x squared, negative 5x, and 6, and my second polynomial has 2x squared and 9. And you can multiply this way too. It's just like reverse factoring, so it works out the exact same. X squared times x squared is x to the 4th. X squared times 9 is 9x squared. Negative 5x times x squared would be negative 5x to the 3rd. Negative 5x times 9 would be negative 45x. And it's a sloppy looking 6 there. But 6 times x squared would be 6x squared, and 6 times 9 would be 54. Now you want your answer in standard form, so your your exponents have to be in the correct order. So look at all these terms now. I have an x to the 4th, and it looks like that's it. So I'm going to start with that. So x to the 4th. Now I have an x to the 3rd, and it looks like that's it as well. So we'll go minus 5x to the 3rd. I have a 9x squared and a 6x squared So I'm going to go ahead and combine those. So 9x squared plus 6x squared would be plus 15x squared. I have a minus 45x. And then plus 54. And then that's it. Your answer is in standard form. You know, just make sure if it doesn't say it like these other two examples, leave it in factored form, you're good. There is one more example for you to do here, which does require standard form. So that means you will have to multiply out. Just a reminder, 4i and negative 3i are the solutions, but you also need to include the conjugates, and that's it.